You are welcome to another edition of our Chemistry JAMB Expo series. And in today's video, we'll be talking about a very important aspect as far as Chemistry JAMB is concerned, known as what? Metals, non-metals, and their separation technique. We are not just going to end there, we are going to solve at least 20 past questions directly on this topic. This particular topic that prompted this particular video was prompted by a request made by a subscriber known as Rita. So Rita, I want to tell you, or I want to let you know that your request has been acknowledged. And if you are looking for any topic you want me to help you break down or help digest it totally for you, feel free to drop it in the comment section. And if you are coming across my channel for the first time, my name is Basi Ejoba. I'm a 400 level student in the University of Calabar studying medical laboratory science. And in my channel, I have students level of the academic game. I also share helpful tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the subscribe button so I can continue getting updates in time I drop videos like this, and so that you can help me grow. And just like I've said, we are focusing on Chemistry JAMB Expo series. We are revealing what you are supposed to know as far as JAMB is concerned. So today we're talking about what the metals and the non-metals and the separation technique. Note that the metals and non-metals are classification of what elements. So in chemistry, we have what is known as what elements. So we have our elements and we have our classification. The first one is known as what? The metals. We have the non-metals. We have the non-metals and we have the metalloids. So you have the elements, you have the metals, you have the non-metals, and we have the what? Metalloids. But for the purpose of this video and for the purpose of the topic that is requested, we are not going to focus on the metalloids. We are just focusing on the what? Metals and the what? Non-metals. So when we talk about the metals, first of all, give you the what? Characteristics of what? Metals. In fact, metal is something that we see every day. Our daily day-to-day activities, we get to see what? Metals. So what is this word? Metals. What are the characteristics of metals? One is that metals are what? Shiny. Metals are stuffs that are what? Shiny. Metals, they are shiny and they can be shaped into what? Wires or what? Sheets. You get to see the zinc that we use. I just mentioned the metal. So the zinc that we use that is shiny, so they can be what? They can be what? Shaped into what? Wires, and they can also be shaped what? Into sheets. And the ability for them to be shaped into wire and into sheets is what we know, or what we call as ductile. This is what we call what? Ductile, or what is also known as malleability. Malleability. So this is the ability of metals to be what? Shaped into what? Wires. So this phenomenon is known as what? Malleability. And also one of the characteristics of metal again is that they can conduct electricity. Metals can also what? Conduct what? Electricity. They can also conduct heat as well. Example of this metal which we talked about is iron. We have copper and we have aluminium. So these are examples of metals and their characteristics. They can be shaped, which is known as ductility. They can conduct electricity and they can also conduct heat. But when we talk about the non-metals is directly a total difference, or totally different, the opposite of what the metal is all about. So we say the metals are shiny, but when it comes to the non-metals are not what? Shiny. So for the non-metals, they are dull. We say what? Non-metals, number one, non-metals are dull. We say they are brittle. They are dull, brittle. Two, we say they can't conduct electricity. So non-metals cannot conduct electricity, neither can they conduct what? Heat. So examples of these non-metals is what we all know as what? Sulfur. Example of non-metals is sulfur. We have oxygen, and we have our nitrogen. So you say a nitrogen or nitrogen. So these are examples of what? Non-metals. Now chemically, all these things I'm saying here, these first characteristics are the physical characteristics of what the moment I mention metal, those are things or non-metal, those are the first characteristics you are supposed to know or supposed to see because they are what physical. But chemically, metals tends to use the word electrons. So metals, when it comes to the chemical reaction, metals will lose our electrons and they form what positive what ions. And in that case, it is what is known as what metals. We have what when metals lose their electrons, they form a positive ions, and that's what called electropositivity. Electron what positivity. That's positive what ions. Therefore, the non-metals don't give out. Instead, what they do is they collect. So for the non-metals, they form what negative ions, and that is what is known as electronegativity. Electronegativity, that is for the non-metals. For example, let me give you a perfect example. A perfect example we have is example sodium. Sodium, which is a metal. Sodium, which is a metal, plus what? Chlorine, which is what? A non-metal. Have you seen it? So sodium, which is a metal, reacting with chlorine, which is what? A non-metal. You get to find out that when you talk about the electrons, you have to bring in the word orbitals. So what is an orbital? An orbital is a region of space where there is a probability, or where there is a 98% probability of finding an electron. So when you go into the orbital feeling, you get to find out that the sodium, which is a metal, has an extra electron, and the chlorine, which is a non-metal, needs an extra electron for it to become what? Balanced. So in this particular case, we say our sodium giving out one electron to chlorine is going to be what? Plus. And our chlorine, which is leading out or which is collecting this electron, becomes what? Minus. That is why chlorine is always what? Electronegative, and sodium is always what? Electropositive. So let's talk about, and you know that the formation of this, the sodium plus chlorine will give us our sodium chloride, which is our normal salt, the table salt we buy from the market and stuff like that. So let's talk about what is ore. Ore, you might have heard about this particular concept known as what? Metal ore. Metal ore. Metal ore. So what is what? Ore. So ores are what? Naturally occurring minerals. Ores are what? Naturally occurring minerals that can be extracted from metals. That can be extracted from metals. That is what is known as what? Ores. But I'm actually putting metal ores so I can be able to what? Understand. So ores are natural occurring minerals that can be extracted from what? Metals, and they are what? Economically what? Valuable. Ores are what? Economically what? Valuable. So we are going to talk about these ores and these metals. I'm going to talk about these metals and the ore they are derived from. Now we talk about the aluminium, we talked about the copper, and talked about mercury and rest. All of them are what? Metals. So we are going to talk about the ores which they are derived from. You know, the aluminium is of economic importance for zinc. The aluminium zinc. You understand? Mercury is also of economic importance. The lead is also of economic importance for pipes. So we want to talk about where these metals are being derived from, which is from their ore. So we want to know the specific ores which they are coming out from or which they are being derived from. So the first one here we have what? Iron. Iron. So iron is derived from hematite. Iron is derived from hematite. Iron is derived from what? Hematite, and or it is also derived from two places. It is derived from what? Hematite, or it's also derived from what? Or what? Magnetite. So the ions is derived from what? Hematite, or it's also derived from what? Magnetite. Then the second one is what? Aluminium. Aluminium comes from what? A ore that is known as what? Bauxite, aluminium comes from a ore that is known as what? Bauxite. That is what is known as aluminium ore. Bauxite is known as what? Aluminium ore. We also have what? Copper. For copper is derived from a ore, is extracted from a ore that is known as what? Chalcopyrite. So copper is derived from what? Chalcopyrite. So iron is derived from hematite or magnetite. Aluminum is derived from bauxite. Copper is derived from chalcopyrite. Then we have lead. Lead is derived from a ore that is known as galena. Lead is derived from a ore that is known as what? Galena. We also have tin. Tin is derived from a ore that is known as what? The calciterite. The tin is derived from what? The calciterite. That is the ore for tin. Then for mercury. Mercury is derived from a ore that is known as what? The cinnabar. So this is basically the metals and their ore. So for ions is derived from what? Hematite or magnetite. Aluminium is derived from what? Bauxite. The copper is derived from the chalcopyrite. The lead is derived from galena. The tin is derived from calciterite, and the mercury is derived from cinnabar. Now, why are ores important? Although I don't even need to tell you why ores are important, because from the name, from what you are seeing here, from the lead to the copper, to the tin, to the mercury, to the iron, to the aluminum, you are supposed to automatically know that these things are important. They are economically important in our society, in our day-to-day activities. So why are ores important? Number one is that they are raw materials for industry. These are all raw materials for industry. You know, it is from these ores that we are able to extract the products, which can either be iron, aluminum, copper, and the rest. So why are they important? Say they are raw materials for industry, iron for steel, aluminum for planes, or copper for wires. But now the question there is this: how do we get these pure metals? The iron, aluminum, how do we get the pure metals from these ores? That is where the concept that is known as what? The separation comes into play. The ability for us to get these metals from these ores is where, or that is where we have what is known as the separation technique when it comes to metal and metal ores. Now, for this method, it depends on how reactive the metal is. For the extraction of these metals depends on how reactive the metal is. So we are going to break it down step by step. This PDF is available. If you need this PDF, feel free to chat me up on WhatsApp, and I'm going to drop this exact PDF for you. It's a summary that I made in order to enable me to share this topic effectively. So the first way these metals are being extracted is, number one, is that they are being crushed. We say what? Crushing and grinding. Crushing and grinding. That is the first way these ores are being extracted. These metals are being extracted. So we say the ores are being broken down into smaller pieces. This makes the process easy, or very easier for the industry to extract these metals from these ores. Secondly is that, the second method there is the concentration. The second method there is the concentration. The impurities found in ores, take note, the impurities, I have to clean this. The impurities found in ores is known as the gangue. That is the impurities found in ores. Impurities is known as the gangue. So these are the impurities that are found in ores. So for us to remove these what impurities, we use methods like the throat flotation for copper or the magnetic separation for what iron. The throat flotation for copper and the what magnetic separation for iron. We are going to get them. Then the next, this is number 1, this is number 2. The next method there, which is the last, is the word extraction. The next method, which is the last, is the word extraction. So the extraction is where you get the word the pure word metals, and different metals need what different word methods. Different metals need what different word metals. Remember, I talked about their reactivity, right? I talked about how reactive how we can be able to separate these various metals from their ores is based on how reactive the metal is. So I will list out how reactive this metal is and their separation. How reactive this metal is, which one is highly reactive, and how we can be able to separate them. Which of them is moderately reactive, and how we can be able to separate them. And which of it is not even that reactive, and how we can also separate them. So the number 1 we have there is highly reactive metals. Highly reactive metals. So number 1 we have what highly reactive metals. For highly reactive metals, example like sodium or aluminium. Sodium or what aluminium, they are extracted through electrolysis. Aluminium is extracted through what electrolysis. Aluminium is extracted what through what electrolysis, and aluminium is what highly reactive. Aluminium is what highly reactive. So aluminium is extracted through electrolysis. Note that the ore for aluminium is what is known as what the bauxite. So for this aluminium to be extracted from the bauxite, electrolysis, and this is simply what using what electric current to what extract these metals, be it the what sodium or be it the what aluminium. Then the second one there is the moderately reactive metals. So the moderately reactive metals, we have the zinc and we have the iron. We have the zinc or we have the what iron, and these can be extracted. They can be extracted using reduction with what carbon. Using reduction with what carbon. Reduction with carbon. Pay attention, I want to say something. Using reduction with carbon. The moment you say using reduction with carbon, that means there must be a blast furnace. A blast furnace. Yes, you see, using reduction with what carbon. Iron is extracted in a blast furnace. Iron is extracted in a blast furnace. Iron is extracted in a blast furnace using either hot air. Coke and limestone reacting to produce molten iron. So you can either use coke, you can either use hot air and limestone reacting together to produce molten iron. Then the last one, which I said it can be highly reactive, moderately reactive, and less reactive. Less reactive, like the copper, are extracted by roasting and smelting. Like the copper is so smelting and roasting. So this is how we are being able to extract copper as a metal through smelting and roasting. So heating the ore to get the metal out, the roasting and smelting is used to convert ore to oxide. Note, there's a concept that I want to introduce now. I want to introduce this concept known as calcination. Calcination is a process whereby ores are being converted to oxide. Calcination, ores are being converted to oxide. So the phenomenon or the process whereby ores are being converted to oxide is known as what? Calcination. So this is just how it is. If you need a summary of all this, it's here. I can just send it to you on WhatsApp. So to have a brief recap of what I've said from the beginning of this class, I talked about the metals, the non-metals. I've talked about the ores and the metals that are being derived from them. I've also given you the meaning of what an ores. So let's talk about separation technique in proper. Let's talk about this separation or technique in proper, which we are currently on. So we also have what is known as what? The froth what? Flotation, which is number 4. The froth flotation is used for what? Sulfide ores. Sulfide ores. Sulfide what? Ores. The sulfide ores use the what? Froth what? Flotation. So for the sulfide ores, we use the what? The froth what? Flotation. Then for magnetic separation, as the name says, is simply for what? Magnetic ores, like the word magnetites or the word hematite. You understand? So which one again? We have leaching. So leaching is simply dissolving the desired what? Metal. You simply dissolve the metal that you want, especially what? Gold, using what? Cyanide. Gold to dissolve in order to dissolve gold in order for you to get it to different what? Shapes that you want to use it for. So you dissolve this desired metal using what is known as what? Cyanide. So this is just the separation technique that is involved. This is the separation technique that is involved in what? Purifying of what? Metals. This is simply the separation technique that is used in what? Extracting of what? These metals from their what? Ores. So this is just it. And the next one I will be going to is to solve at least 20 what? Past question based on this particular topic to see how far we are going to test ourselves. These questions are directly gotten from JAMB past questions and answers, and there's every possibility that questions is going to come out from here. So let's head forward to our question section. So for the questions, we'll be focusing mainly on at least 20 past questions and answers based on metals, non-metals, and a separation what? Technique. So number 1 we have here on the board is which of the following is supposed to be which of the following is the properties of metals. So which of the following is the properties of metals? A. Low melting point. B. High electrical conductivity. C. Brittle nature. And D. Poor thermal conductivity. Remember in the beginning of the class, I already told you the properties of what? Metals. So one of the properties of metals is that they are shiny. That is, they can also be transformed into what? Sheets and different what? Shapes. That means they are shiny, they are ductile, malleability, they can conduct electricity and what? Heat, high thermal conductivity. And if you don't check all what is here, A. Low melting point. No. Metals have high melting point. B. High electrical conductivity is correct. And C. Brittle nature. Brittle nature is an example of what? Non-metals. And D. Poor thermal conductivity. 2. Non-metals are generally poor conductors of electricity except for A. Sulfur, B. Graphite, C. Phosphorus, and D. Chlorine. Note that the question is non-metals. Non-metals generally are poor conductors of what? Electricity. But now we are looking for the exception here. We are looking for the word exception that is here. So we have sulfur, we have graphite, we have phosphorus, and we have what? Chlorine. For the chlorine, the phosphorus, and the sulfur are wrong. The correct answer here is what? Graphite. Remember the allotropes of carbon which you have with the diamond and the word graphite. Note that diamond cannot conduct what? Electricity. But graphite, despite being the fact that it is a non-metal, can also conduct what? Electricity. Because it allows what? A valence electron to pass through it. As it allows the flows of what? Electrons. So the moment it allows the flow of electron, then it means it can conduct electricity. And graphite, one of the properties of graphite is that it can conduct electricity. So graphite is an exception of non-metals that cannot conduct what? Electricity. The third one is what? The ore of iron commonly used in the extraction of iron is A. Borazite, B. Hematite, C. Cassiterite, and D. Galena. Remember when I gave you the ores and the ways you can be able to extract them, and also the ores and ways you can be able to extract them. I gave you different ores. I gave you borazite for aluminium, and I gave you ions for hematite. So the answer here, the ore of iron commonly used in the extraction of iron, the iron ores is known as what? Hematite. Remember I gave you two names. I say the hematite or the magnetite. So when the magnetite is not here, the next answer there is the word hematite. Let's move on to the fourth question. The process of separating a metal from its ore is called A. Alloying, wrong, B. Smelting, C. Refining, D. Corrosion. The answer here is what? Smelting. The answer there was smelting. Remember I gave you separation, the separation where you can be able to separate this metal, and which one of them that I say there is what? The smelting or the what? Roasting. So if you check all of this here, it's not even what? A method or separation or technique when it comes to what? Metals. So the correct answer here is the what? Smelting. Number 5. Which method is used to purify copper after extraction? Remember I talked about purification. After extracting. Remember I talked about the purification. We have A. The fruit flotation, wrong. We have electrolysis, we have distillation, and we have the magnetic separation. For the purification of copper after extraction, we use the word electrolysis. So electrolysis B is what? Correct. The extraction of copper and the word for the purification is different. The extraction and the purification is what? Actually what? Different. But for the purification here is what? Electrolysis. Remember I already told you this in the beginning of the class. Number 6 says fruit flotation is commonly used in the concentration of A. Hematite, B. Sulfide ores, C. Borazite, and D. Limestone. The correct answer here is what? Sulfide ores. For the flotation of what? Fruit flotation that is commonly used in the concentration of what? When it comes to what? Sulfide ores. Let's move on to the next question, number 7. The main reducing agent in the extraction of iron in the blast furnace. Remember I talked about the blast furnace. And one of the things or one of the elements I mentioned when I talked about the blast furnace, I talked about carbon. And in cycle I talked about air, I talked about coke. So now the question is, the reducing agents in the extraction of iron in the blast furnace is A. Carbon dioxide, B. Carbon monoxide, C. Limestone, and D. Oxygen. You get to find out that C and D are not even part of the word option, are not even close to the word options or to the answer. We are left with what? Carbon dioxide and carbon monoxide. The correct answer there is what? Carbon monoxide. The correct answer there is what? Carbon monoxide. Number 8 is which of the following metal is extracted by what? Electrolysis. We don't even have the word tin. The metal that is extracted by electrolysis is what? Aluminium. Note, there's option about copper, but I'm not saying it is copper because copper at electrolysis is not used in the extraction of copper. Rather, it is used in the purification of what? Copper afterward extraction. The next question here is the ore cassiterite is associated with which metal? The ore cassiterite is associated with which metal? A. Zinc, B. Tin, C. Lead, and D. Copper. The correct answer there is what? Tin. Tin is extracted from the ore that is known as what? Cassiterite. Question number 10. Which of the following is a non-metal? Which of the following is what? A non-metal. A. Sodium, B. Sulfur, C. Calcium, and D. Iron. Sodium is a metal. Sodium is what? Now how do you know that it's a metal? Sodium is what? Electropositive. Calcium is what? Electropositive. And ions are what? Electropositive. So the answer there is what? Sulfur. Sulfur is what? Electronegative. And electronegative elements are not what? Metals. So which of the following is a non-metal? Sodium, sulfur, calcium, and what? Iron. The correct answer there is what? Sulfur. Sulfur is what? Electronegative. And hence, being electronegative, it cannot be a what? Metal. The next question there is what? Number 11. The process of heating an ore in the presence of air. This one is not even something you're supposed to even calculate. The presence of heating an ore in the presence of air to remove impurities is A. Roasting, B. Smelting, C. Leaching, and D. Calcination. The answer is what? Roasting. You what? Heat what? Air. You heat what? A metal, sorry. Or a ore, sorry. Heat a what? Metal ore in the presence of what? Air. We all know what it means to heat something in the presence of what? Air. What is the answer is known as what? Roasting. The next question. Which separation technique is used to separate magnetic ores like magnetite? Which separation technique is used to separate magnetic ores like magnetite? A. Froth flotation, B. Magnetic separation, C. Gravity separation, and D. What? Electrolysis. The answer there is what? Magnetic what? Separation. Remember, magnetic is magnetite or hematite is for what? Ions, and the separation of ions is what? The magnetic what? Separation. Question 13. The major impurity removed during the extraction of iron in the blast furnace. Remember we talked about the blast furnace, so we use the carbon what? Monoxide as a what? Reducing what? Agent. So the major impurity that is removed during the extraction of this iron in the blast furnace is A. Silica, B. Sulfur, C. Carbon, and D. Phosphorus. The answer there is what? A, which is what? Silica. 14. Which of the following metals is found in its native state? Native state simply means what? Natural what? State. Which of this metal that you get it naturally? It is the way it is. You don't get it from, there's not like a particular ore where you extract it from. We have A. Sodium. No, sodium is being extracted from a ore. We have gold. We have aluminium, which is wrong. And we have what? Iron. So the correct answer there is what? Gold. Gold is gotten from its what? Native, or what we call the what? Natural what? State. 15. The process of converting an ore to its oxide by heating. The process of converting an ore to its oxide by heating in the absence of air is called, remember the question we answered the other time, it was the process of what? Heating in the presence of air, which was what? Roasting. But this particular one is the absence of what? Air. We have A. Roasting, B. Calcination, C. Smelting, and D. Leaching. The answer there is what? Calcination. Calcination is simply converting an ore to its oxide in the absence of what? Air. 16. Which of the following is used as a flux in the extraction of iron? Which of the following is used as flux in the extraction of what? Iron in the burning what? In the furnace, in the blasting furnace? A. Limestone, B. Coke, C. Hematite, and D. Carbon monoxide. The answer there is what? Limestone. Limestone is used as what? A flux in the what? Extraction of what? Iron. 17. Which non-metal is essential in the vulcanization of what? Rubber? Vulcanizers. Which non-metal is essential for vulcanizers in the vulcanization of what? Rubber? We have A. Nitrogen, B. Sulfur, C. Oxygen, and D. Chlorine. The correct answer there is not nitrogen, neither is it oxygen, and neither it is what? Chlorine. So therefore, the correct answer there is what? Sulfur. Sulfur is used, or is a non-metal that is very essential in the vulcanization of what? Rubber. The 18, which is the last question here, is what? The Bayer process is associated with the purification of which ore? A. Hematite, B. Boazite, C. Galena, and D. Cassiterite. The answer there is what? Boazite. It is what? A process, the Bayer process, it is associated with the purification of ore, which is known as boazite, which we extract our aluminium from the what? Boazite. So these are essential questions which I was able to get from this topic that is known as metals and non-metals, and there was separation what? Technique. If you love this video and you really wish to score high in your JAMB exam, please don't forget to hit on the red subscribe button, and also drop in the comment section your dream JAMB score. If there's any topic, like I said, that's giving you issue both in chemistry and biology, feel free to drop it in the comment section, and I will see how I will be able to produce this video for you and for other JAMBites. If you are looking for past questions, also feel free to chat me up on WhatsApp, drop it in the comment section, and I will make sure I'll draw my WhatsApp number with you, and chat me up on WhatsApp, and I will gladly share these past questions with you. Note that scoring high in your JAMB is very possible, but you can only get this when you cut off distractions, when you focus on what is really important, and that is smashing your JAMB and getting admission to study your dream score. I'll see you in my next video. Always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I will love you.